DEEE 2V06 and we are presenting on our e-learning assignments, which is on lesson 4 numerical integration. Yeah, so we go into section A of the numerical integration. So question 1, what is numerical integration? Numerical integration is the approximate computation of an integral using numerical techniques. And why and when should this numerical integration be applied on? There are two main reasons for you to need to do numerical integration. Firstly, is the analytical integration may be impossible or infeasible, or you may wish to integrate tabulated data rather than known functions. Okay, so there are several reasons for carrying out numerical integration. The integrand f may be known only at certain points, such as obtained by sampling. Some embedded systems and other computer applications may need numerical integrations for this reason. So a formula for the integrand may be known, but it may be difficult or impossible to find an antiderivative, which is an elementary function. It may be possible to find an antiderivative symbolically, but it may be easier to compute a numerical approximation than to compute the antiderivative. That may be the case if the antiderivative is given as an infinite series or product, or if its evaluation requires a special function which is not available. Okay, so you move on to question 3, which is what is trapezoidal rule? So this is roughly the formula of what is trapezoidal rule. Yeah, so which is the integral fx that dx is equals to b minus a over 2n. Yeah, n is a function and bracket fx 0 plus 2 fx1 plus 2 fx2 and so on. So this is a pattern, number pattern. So in mathematics, the trapezoidal rule is a way to approximately calculate the definite integral. The trapezoidal rule works by approximating the region under the graph of the function fx by a trapezium and calculating its area. To calculate this integral more accurately, one first splits the interval of integration of a and b into n smaller sub-intervals and then apply the trapezoidal rule on each of them. So,
I will be doing question 4 on how to apply the rule and any constraint of using it. So I will be using chapter 4, tutorial 4, question number 1 to present on how we apply the rule. So question 1, given the equation with n equals to 6, we will first use the formula with let fx equals to the equation and h equals to b minus a over n, which will get us the value of 0.5, which is the interval between each strips. So as you know, the strips, there are 6 strips. So by making out the table and submitting the numerical value to x, you'll get the following answer. So by the trapezoidal rule, with the equation and the formula given, we sub in the numerical value, which is so on and so on, will get us the value of 28.55. And the constraint on using the rule is that there's a lot of steps to do, so it's quite tedious. And question 5, the advantages and the disadvantages. First, the advantage is one of the two formulas to calculate the answer for the equation, and the disadvantages is if there's any calculation error, the whole answer will be wrong. There will be more detailed advantages and disadvantages explained in our section D.